Uh, okay. Welcome to our day two notes for Algebra 1. And in day two, we'll be talking about how to identify investigative questions and the two big conditions that define investigative questions. An investigative question uses both bivariate and quantitative data. Bivariate means there should be two variables, which is the independent and the dependent variables. And quantitative means the data should be represented by a number. So it should be a numeric value represented by a number. Now, we have four questions, and we want to determine if those four questions are the examples of an investigative question or not an example. And if not, we want to write down the reason why. Here, the first question is, what is the average salary of lawyers? Here, this is not an example. It's because you only have one variable. So it is not bivariate. There's only one variable, which is the average salary of lawyers. We need at least two variables. So if you look at the next one, it says, what type of relationship exists between salary and years of experience? This is a good example because you have two variables, salary and experience, number of experience, and both can be counted as a number. So that is a good example. Now, what about the third example? Is there a relationship between university attended and salary of lawyers? The answer is no. It's because even though you have two variables, each of the variables should be countable. It should be a quantitative data. But look at this example. University attended. You cannot count a university attended. Like Virginia Commonwealth University, like George Mason University, it has names, but you cannot count those as a number like one, University 2, University 3. That's the reason why there's another example, and the reason is university attended university attended is not quantitative. The last example is there a relationship between number of clients and salary for lawyers? Again, always check if we have two variables. We have number of clients and salary of lawyers. So yes, you do have two variables, so you have bivariate. Is it quantitative? Can you actually count those variables? You have number of clients, which you can actually count the number of clients, like client 1, client 2, client 3, and salary for lawyers. You can count how much money they make. Therefore, both variables are countable, aka quantitative. Therefore, this is a good example. Now, here, before I move on to the next one, we have reviewed what are the examples and what are the non-examples, and two things that we should consider when we are talking about the example and non-example, which is it should be bivariate, two variables, and quantitative, represented by a number. Now let's move on. Here, it already gives you an investigative question, so it is already an example. Here, we want to identify the independent and the dependent variable. Independent variable is usually represented as an x, and the dependent variable is represented as a y. Independent variable is simply a solo variable that it doesn't get affected by something else. while the dependent variable is the variable that it is like affected by the independent variable, so it's very dependent by some other data, so it's called as a dependent variable. Here, if you look at the question, it's asking you, is there a relationship between a person's height and their hand size? Usually by context, it's always the first one that is the independent variable. So in this case, it's going to be height. And what is my dependent variable? It's the hand size. Let's move on to the next example. Does the number of left turns, so that is one of my variables, I take while driving affect how many gallons of gas I use? Here, the left turn affects the gallons of gas you use, so therefore the independent variable is the number of left turns, while the number of left turns like affect the gallons of gas. So that is dependent variable. So before I move on, we have learned how to identify the independent variable and the dependent variable. The independent variable is a solo variable that it does not get affected, while the dependent variable does get affected by the independent variable. Now, let's move on to some SOL questions. So on the SOL, it gives you like multiple examples, and I would like to go one by one and also some tricks that will help you to understand which one is an investigative question. The first trick is to label the independent variable, this is an acronym, and the dependent variable. And the ensure data is a bivariate data and quantitative. Again, your bivariate data is two data, and a quantitative data is a data can be represented as a number. And to do that, avoid words. Okay, I think I went super fast. Just a minute. So like on the SO questions, there are, as you read through the choices, there are gonna be specific magic words where you can just avoid, and magic words that you can focus on. If on the example, if you see words like this that I'm gonna write, avoid it. Usually that is not the answer, and those words are cause, always, and definitely. And you should focus on words like, oh, excuse me, relationship, typically, likely, and correlation. If you see those words, focus on it. Now, let's actually read the question. I have like 4 examples that will help you for the SO exam, and let's go over one by one. Okay, you want to explore the relationship between number of pets and self-reported happiness level on a scale of 1 to 10. So you have those two variables. Which is the best investigative question to explore this? And you have like 4 choices, and we're going to check if those are good questions, good examples. First, if I adopt a dog, how happy will I be? That is indeed a very bad example because it has the word I, that means there's only one data. If you only have one data, then you cannot even have a scatter plot on a statistics. So the more the data is a good data, but you only have one data, so it's a bad example. I'm gonna skip B. I'm gonna move on to C because I want to show you guys the bad examples first. How many pets does everyone have? Okay, guys. How many variables do I have here? How many pets does everyone have? Here, I only have one variable. Therefore, that is not a good data because how many data do I need? 2 data. Let's move on to the example D. Does the number of pets owned cause people to be more happy? Guys, what did I told you? The magic word. Cause. Under avoiding the words like cause, and cause is one of the words you should avoid. So here, when you guys see the word cause, you can like 99% automatically erase that word. And what is the answer? Only answer choice left? If the number of pets owned increases, does the person's happiness level typically increase? Well, that's the only answer choice left, so that should be the answer. But this is the answer because it has the word typically, which is the word you should focus on. Therefore, that is the answer. B. Let's move on to the next example. You are studying the effect of rainfall amount on umbrella sales. So I have two variables, rainfall amount and umbrella sales. And I want to know the best investigative question. The choice A, let's read it. Does an increase in rainfall always result in an increase in umbrella sales? You see there is a magic word of always. Again, that's a word you should avoid. So therefore, this is not the answer. There's nothing as like always cause, definitely. No. Please avoid that. Let's look at the second example. How much money can I make selling umbrellas if there is heavy rain today? This is a bad question because, guys, look at it. I have to use this one. I. And what does this I mean? There's only one data, and as I did on the previous question, one data is not enough. So this is a bad example. Okay, question C is what I want to actually highlight on, because if you see this word, the magic word where you should focus on, it has the word typically. Do you guys see that? So you're gonna think, oh, it has the magic word that I should focus on, it should be the answer. But be careful on what the variables are. Before the word typically, what does it tell you? Selling yellow umbrellas. Am I selling just yellow umbrellas on my question? No, because before it wants you to just get the general umbrella sales, not just the yellow umbrella. Here, your question should have the exact matching name of the variable. So even though it has the word typically, because the variable does not match, this is not a good example. Let's move on to the last example. Well, that should be the answer automatically, but let's review it together. If it rains a lot, are umbrella sales more likely to increase or decrease? Guys, the word likely, and that is a word you should focus on. And compared to example C, the name of the variables match. Therefore, the answer is D. So I love question 4 because it has a trick answer choice where lots of students can fall for. That's the reason why in statistics in Unit 1, reading is so much important. So I recommend you guys to actually highlight the variables as you guys are reading the questions. Or at least underline it if you have no highlighter. Now let's move on to the remaining two questions. Here, before I move on, I want to highlight the independent variables and the dependent variables. Again, the independent variable is always x-axis and the dependent variable is the y-axis. Have that in mind. Now, let's answer those questions. Like if this is my scatter plot, like what kind of answer questions we can like think? Like what are the good questions? Let's read the first one. If your age increases, will you definitely use less ice cream toppings? Again, what do you guys see? Definitely. That is the word where you should avoid. So that is, I'm just gonna do it purple. Why not? That is not a good example or not a good question. Gotcha. Now, let's look at the second one. If a person gets older, are they more likely to eat ice cream? This is a wrong answer, even though it has the good example likely. The reason why this is wrong is because what is my independent variable? Is it eating ice cream or is it number of ice cream toppings? Like I told you, the name of the variable should match, so that is also not a good example. Now, let's move on to the last one. Is there a relationship between age and number of ice cream toppings? I love this word, relationship. That is a word you should focus on. And my name of the variables match the age and the number of ice cream toppings. So that is a good question. Now let's move on to the last one. Here, my independent variable is sunlight, and the dependent variable is plant growth. My first question is, does an increase in sunlight correlate to an increase in plant growth? It is correct, because it does have a good word, correlate, and the name of the variables match, the sunlight and the increase in plant growth. So this is a good example. What about the second one? Does a plant that grows taller cause the sun to stay out from the clouds? Cause. Oh, my bad. That should be in a red color. That is a word you should avoid, right? So that is not a good example. Last one. If I leave a plant in the sun for a long time, is it more likely to grow? Do you guys see that? Excuse me, I don't know why it moved. Do you guys see the magic word likely? The word you should focus on? And uh, leaving the plant in the sunlight and the plant growth, the name of the variables also match, even though it's kind of worded differently, but they're talking about the same thing, the sunlight and the plant growth. Therefore, this is also a good example. So before I close today's video, do the practice by yourself as a homework. And we went over investigative questions. There should be two conditions. There should be two variables, and it should be a quantitative represented by a number. And we went over various examples on which is example and which is not example. And we also went over words that you should avoid. Oh, excuse me. I don't know why that's like going across. We should focus on like what are the words that you should avoid and the word you should focus on. And we went over some SOL questions and went over why is it a good example and why is it not a good example. Thank you for watching this video and have a nice day.